Static code analysis is an automated process that examines source code for errors, vulnerabilities, and code quality issues without needing to execute the program. It helps developer catch bugs, force coding standard, and improve security early in the development process, making code more reliable and maintainable. Hi everyone, welcome back. In this video, we will integrate SpotBugs into a Maven project for advanced static code analysis. I will show you how to configure the plugin, run bug checks, and refine your results by including or excluding specific bug patterns and source files. For this demo, we will reuse our older HTTP file server. In our HTTP file server, we had two files, fileserver.java, which is the main file, and file request handler, which is there for handling the request. Now this is the Maven project and we have our pom.xml. As you can see, I have added this new plugin module. So we are going to use SpotBugs plugin. We are going to use its latest available version, and then we are going to define the dependency on which the plugin depends. Now to run this, we can simply execute SpotBugs check target. As you can see, SpotBugs has reported 5 errors or bugs in our code. SpotBugs analyzes the compiled source code and it shows the detected issues in the output. So if we go ahead and see, it says that there is a possible null pointer dereference in file request handler, and that is at line number 130. So let's go ahead and check line number 130. So as we can see in the line number 130, there is indeed a possible null pointer dereference because the getFileName method is bound to return null in certain cases. And we can see SpotBugs reports other issues along with this possible null pointer dereference. Now we will have a look how we can integrate SpotBugs in our Maven compile workflow. So to do that, we will go back to our pom.xml and let's add an execution block. In the execution, we'll add a new execution. It's an ID. For this, we'll simply call it check. And let's define the phase where it should run. So I'll say it should run in the compile phase. And let's define which goal we want to run in the compile phase. So I'll say run the goal check. Now let's go ahead and compile our project. As we can see, the compilation phase has executed the SpotBugs check target and it reports the same errors that we saw earlier. So this is how we can integrate the SpotBugs and thus the static code analysis in our compilation workflow. And it gives us a very good pipeline which allows us to catch the bugs early on in the development. We can further refine SpotBugs result by using include filter file and exclude filter file. Include filter file can be used to focus on specific patterns and bugs, and similarly exclude filter file can be used to exclude certain set of bugs. Let's see quick examples. Let's go ahead and define an include filter file where we say that we only want to focus on null on some path return value. I will create a filter file in main resources and let's create a new XML file. Let's define the top level element, which is findbugs filter match, and here we will say that we only want to match bug pattern equal to, that's it. So only this bug will be matched. Let's go ahead and verify it. Before that, we need to reference this include filter file in our pom.xml configuration. In the plugin, we will define configurations. In the configuration, let's add an include filter file and define the file path, which is resources slash spotbugs config and include filter.xml, and let's go ahead and run the compile again. It says it cannot find resources. After using the correct file path, we can see that SpotBugs is only reporting the NP null on some path from return value error, and it is not returning the other errors that it returned before. So this is how we can use include filters. Now let's quickly check an example of exclude filter. First, I already have an exclude filter file created. So let me just reference that over here, and let me open the file. We will say that we want to exclude the bug pattern that we've just created recently. Now essentially what this will do is this will not return any bug in the compile and our compile will be successful. So let's try and test that. So SpotBugs is running and we can see that the build is successful. These filters are really helpful tool and you can read more about these filters in the SpotBugs documentation. These filters are really good way to fine tuning our filters for a best balance between actionable feedback and noise reduction. So as we have seen that integrating SpotBugs with Maven and customizing filters is essential for maintaining a clean and production ready code. If you enjoyed this video or want more on advanced code analysis tools, subscribe and let me know in the comments.